Good morning students. Today we will have some introduction of a microprocessor, that is a Pentium microprocessor. My name is Sonali Antad, Assistant Professor from Department of Computer Engineering, VIT Pune. The content of this microprocessor presentation is what is a microprocessor, evolution of a microprocessor, introduction to Pentium processor and its features. What is a microprocessor is? Your computer's CPU, that is central processing unit, that is built on single integrated circuit, is called as a microprocessor. It is a programmable device that takes an input and performs some arithmetic and logical operations over it and then produces the expected output. A microprocessor is a digital device on a silicon chip and that can fetch the instruction from memory. It decode the instruction and execute them and get the expected results. A microprocessor can take a bunch of instructions in assembly level language and executes them. The microprocessor contains millions of tiny components like transistors, resistors and diodes, and they are working together. There are two types of processors. One is a CISC. CISC stands for Complex Instruction Set Computing. Example is a Pentium 486. These microprocessors are having complex instruction set and complex addressing mode. The another one is RISC, that stands for Reduced Instruction Set Computing, where its instruction set is a very simple one and very less number of instructions are available. Its addressing mode are also simple. This is a typical structure of any microprocessor. A microprocessor inside it having an ALU, that is arithmetical and logical unit, where actually any arithmetical operations like addition, subtraction, multiplication, division, logical operations like logical and, or, not get executed. It is having some control unit that controls the execution of the instructions. It is also having temporary storage in terms of register array. It is having a program counter register that points to the current instruction executing. It is also having another register that is named as IP, that is instruction pointer. Always instruction pointer fetch the next instruction that is to be executed. Program counter calculates the address and sends on the address bus. At the from particular that memory address, the instruction is fetched and data is fetched from the memory and that is loaded into the register, and one copy of that one is sent to the instruction decoder unit. Instruction decoder unit decode that what is the meaning of that instruction. According to that instruction execution takes place, whether it is a arithmetic instruction, logical instruction, and after execution the particular flag will be going to be set into the flag register. If carry is generated after addition or subtraction, if any result is a 0, result is a negative, then sign flag will going to set. There is a overflow flag, direction flag, trap flag. There are three types of buses inside the microprocessor, that is address bus, control bus and data bus. So this is a typical structure of any microprocessor is. Now we will see how the evolution of microprocessor takes place. The first generation microprocessor is just a 4-bit microprocessor, and that is developed by Intel in the year 1971-72. That is a 4-bit microprocessor whose name is 4004. It is called as a 4-bit microprocessor means it is having a data bus of 4-bit. The operands it can execute at a time is of a 4-bit. The second generation microprocessor is again improvement that is done in 1973 while Intel introduced its first 8-bit microprocessor, that is 8008. Later it is improved as 8088. This is a 8-bit microprocessor means its data bus is of 8-bit and it can process at a time 8-bit operands. The third gen generation microprocessors are 16-bit microprocessor which are introduced in 1978 by Intel as a microprocessor list series 8086. 186 is not introduced in the market. Afterwards it's a 80286. Both are 16-bit processors and they are performing like mini computers. The fourth generation microprocessor, that is a 32-bit processor, means the data bus to the microprocessor is a 32-bit. At a time 32-bit operands it can execute, means as number of bits increased it can the speed of the microprocessor is also increased, and the popular microprocessor introduced by Intel is 80386. From 1995 till today, this is a fifth generation microprocessor which are 64-bit microprocessor. Means their data bus is of a 64-bit and their operand it can execute at a time is a 64-bit. So after 80586, Intel comes out with a new processor that is called as a Pentium processors, and that is followed by Pentium Pro and CPU. Now we will have some introduction of a Pentium. Just now we have seen that Intel Corporation introduced Pentium in 1993. It is also called as a Pentium 1, P5. Some people are referring it as a 80586 because it is a fifth generation microprocessor. At that time it was totally captured personal computer market because of its support to the computer graphics and multimedia. It is used everywhere from dedicated control systems to super-fast network file servers. It is compatible with previous 886 microprocessor and 386 microprocessor with many improvements. Means in a Pentium, 886 and 386 program can also be executed in its virtual 886 mode. Pentium 1 processor mainly includes 64-bit processing. It can have operands at a time. 64-bit data it can process. It is having 16 KB L1 cache memory available, and it is also having fast serial bus with a frequency of 66 MHz, and its clock speed ranges from 66 Hz onwards. There are different Pentium microprocessors available in addition with Pentium 1, that is Pentium 2, Pentium 3, Pentium 4, Pentium M, dual core. These microprocessors include approximately 3.1 million transistors, a 64-bit external data bus, also 32-bit address bus. As it is having 32-bit address bus, so how much physical memory it can address or access is depends upon the formula 2 raised to k, where k is nothing but number of address bits. So 2 raised to 32 means it can address up to 4 GB of physical memory. Now we will see features of Pentium. Pentium introduced in 1993 by the Intel Corporation with frequency ranging from 60 to 66 MHz. The primary features of Pentium processor is it is a superscalar architecture. It is also called as a superscalar super pipeline architecture. Why it is called so? Because it is having two pipelines to execute the instruction. They are namely U pipeline and V pipeline. Other previous all processors are having single pipelines. That is why they can execute one instruction at a time. But due to availability of two pipelines and two ALUs, so Pentium can execute two instructions per clock cycle. That is why it is called as a superscalar architecture. It is having a dynamic branch prediction, that is in terms of BTB, branch target buffer. Normally what happens whenever sequential execution is going on, so both the instruction queue, that is U and V, are loaded with all the instruction. But whenever there is a control transfer instruction takes place, so whatever loaded previously instruction becomes invalid. So they should be discarded from the pipeline, and new instruction from the new target address wherever control transfer is going on should be loaded into the pipeline. And this total process takes place sometime, and it will takes some clock periods, and earlier clock periods are vested, in which all the instructions are sequentially loaded into the pipeline. In such cases, microprocessor may go into the waiting state, and that is why there is a vestige of clock periods. To avoid this, or sometimes it may happen that in the pipeline empty space will be going to be created, that is called as a bubbles. To avoid that, in advance prediction has to be made that whether to take a control transfer to any target address or not. To make a branch prediction, for that this is called as a dynamic branch prediction, and that Pentium performs in with the help of its one of the unit that is called as a branch target buffer. Then it is having pipeline floating point unit. 386 before, all the microprocessors are not having capability to perform floating point operations as well as mathematical operations. For that, external chip that is called as math coprocessor should be connected with the microprocessor, and due to that sometimes there may be congestion for the buses between microprocessor and the math coprocessor. Like 8086 has to be connected with 8087, 80386 has to be connected with 80487, 387. So such a math coprocessor is not connected with Pentium, but it is having on-chip pipeline floating point unit on it. So there is a separate floating point unit, and it is having its instruction execution 8-stage pipelining is there. It is also having separate 16K L1 cache memory. Out of 16K, 8K is assigned to the code and 8K is assigned to the data. Due to that, its processing speed is very faster. Means due to cache memory, the interaction between microprocessor and external memory is minimized, because one copy of the data that is frequently needed or the instruction that is frequently needed will be stored in this cache memory. Write back MESI protocol in the data cache. Pipelining in the Pentium consisting of 5 stages. Its execution takes place in 5 stages. First is a prefetch. Second is a D1, in which decoding of the instruction takes place. In D2, the wherever is the operand, its address will be calculated. If first it will be searched into the cache memory. If it is available, then it will go to the next stage. But if it is not available, then it will be brought from the either external cache memory or main memory into the internal cache. After that, it goes to the next stage, that is execute. And in execute, the instruction will be executed into the ALU with the temporary storage of its register set. Pentium is having a rich set of registers. After executing, then data may be updated into the registers or memory memory, so that there is a write back MESI protocol takes place. It is having a 64-bit data bus. Pentium is having 64-bit data bus and 32-bit address bus separately. In 8086, the address bus and data bus are multiplexed. Means same address bus and data bus are using on the same pins, but here separation is done totally. Actually, the Pentium's all registers are of 32-bit, but it is having two 32-bit ALUs. That is why it can execute at a time 64-bit operands at a time. So its data bus of 64-bit. Then bus cycle pipelining. It is just now we have discussed, it is having its pipelining consisting of 5 stages, namely as prefetch, decode 1, decode 2, execute and write back. And due to this 5-stage pipelining, and it is having two pipelines, U pipeline and V pipeline, 10 instructions will be present at a time in pipelining. There is no any waiting state comes for the microprocessor, that due to unavailability of a instruction. So this is what the bus cycle pipelining is. These are the very important features of a Pentium. So today we will stop here. Thank you for listening.